Okay, so this is the first day of vectors. They're pretty simple things if you pay attention to them. We treat them a lot like we treat points with a couple of different vocabulary, right? So we have vocabulary that we need to know. So the first thing is the notation. What do vectors look like? How do you know it's a vector? Well, you know it's a vector if we have something written in chevrons. So these pointy brackets or parentheses, these are called chevrons. So if we have it in a point form or a coordinate form with chevrons, that is one way that we are looking at a vector. Okay, so it has an x component and a y component. The x stuff, of course, tells you how far to go left or right, and the y component tells you how far to go up or down. Okay, so you can have it written as a chevron, or you can have it written in what's called a linear combination, where we have two parts to our linear combination, an A part and a B part. Well, those are both numbers, but the combination part are your I's and your J's. Okay, so just like X and Y, the AI is your horizontal part. Positives are right, negatives go left. And the B is the Y part. Positives go up, negatives go down. So we're changing up this axis, and we're just calling the positive or the x-axis the I-axis, and we're calling the y-axis the j-axis. Okay. So once again, this is called a linear combination. So how else? Well, we can call the vectors. They have names, right? So you can call the vector. Usually they're called V vectors or V, and they have this little half arrow over the top of them, like V or U, often, or W. These are really the three vectors, letters that we use all the time. So maybe let's say we have the vector 3 minus 2. Okay, so this is vector 3 minus 2. That's how we would write it, as chevrons or in component form, or as a linear combination. That would be 3i minus 2j. Okay, 3i minus 2j. So basically what's happening here is we can plot this like we plot a coordinate. So if we start at the origin as your initial point, you can go 3 units to the right and 2 units down. And this is the vector that goes from the origin to the point 3, negative 2. So it always has an arrow on it because vectors have direction. It matters where your vector starts and where your vector ends. So that would be the vector 3, negative 2, or the vector 3i minus 2j. Okay, so we can calculate some things. Most importantly would be the magnitude. Now the magnitude has a special notation, and it has like these double absolute value bars around it. That's how you know you're being asked for magnitude, because of this notation. Okay, so the magnitude is basically the length of that line. And we can calculate the length of the line by using the Pythagorean theorem if you create a nice right triangle. And that's what we're going to do. The magnitude is always found by using the Pythagorean theorem. So the square root of the x distance traveled plus the y distance traveled. Okay, so this is how we find the magnitude of your vector, or the length of your vector. The vector you can consider the hypotenuse of a right triangle. So if we're finding the magnitude of 3, negative 2, that would be 3 squared plus negative 2 squared. Okay, as 3 is your x component and negative 2 is your y component. So 3 squared is, of course, 9. Negative 2 squared is positive 4. So this vector would have a magnitude of the square root of 13. And it's perfectly fine, at least in my class, to leave your answer as a radical. You do not have to put that into a calculator and make it into a decimal. Okay, so radicals are fine for the magnitude of vectors. So once again, the magnitude of a vector is its length, and it's often found by doing the Pythagorean theorem. So you can think of the magnitude as the hypotenuse of a right triangle with an x component and a y component. Okay, let's see what else. Find the vector from the initial point P at 3 minus 2. So we have a grid here. 3 minus 2 is right there. So there's point P. To the terminal point. So initial point is where we're starting, and terminal point is where we're ending. So think about an airplane flight. We get on the flight at the initial place, and then you end at the terminal place, right? That's where your flight ends. Terminal means end. So minus 7 comma 5, that's up here. We're ending at Q. So we start at P, we get on the plane at P, and we fly up here to Q. So Q has the arrow on it, and that's going to be our vector. So in order to figure out what that vector is, right, it says find the vector. Let's just call this vector V for fun. Nope, we're not going to call it V. We're going to call it PQ. Starts at P, goes in the direction of Q. We're going to create a right triangle. So we just go horizontally until we are underneath that point. And then we're going to go vertically until we run into that point. And now it's simply a matter of counting. From -3, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to the left, so a -10. Okay, whenever you go left, that's a negative direction for coordinates. So -10. And then counting up, we go 1, 2, 3, 4, 5, 6, 7. So that's a +7. So in other words, our vector is going to be with chevrons. If you want to use chevrons, we'll do them both. -10, comma 7. So that is the component form of our vector from initial point -3 or 3, -2 up to -7, 5. So as a linear combination formed with i's and j's, okay, that would be -10i plus 7j. So just another way to write it as a linear combination, -10i plus 7j, or with chevrons, -10, 7. And then it asks us to calculate this. Okay, so you need to know that this notation means magnitude. So the magnitude of the vector from P to Q is found by doing the Pythagorean theorem. -10, which is your x component squared, plus 7, which is your y component squared. Okay, so this is just a matter of adding 100 to 49 and getting the square root of 149. Okay, which in your calculator is a little bit bigger than 12 point something, right? But the square root of 49 is perfectly fine to use as your answer. Okay, unless your teacher wants a decimal, and then make it as a decimal. So how about some vector operations if we're going to add or subtract vectors? Okay, so maybe we have the vector a comma b, right, some random vector, and the vector x comma y. Well, adding vectors together just means that you combine their components. So the x component would combine to the x component, and the y component would combine with the y component. So if we're adding them together, then it's the x stuff added together and the y stuff added together. And if you're subtracting them, then, well, it's the x stuff minus each other and the y stuff minus each other. Okay, pretty simple. You just add the like terms. So it says that we have two vectors, v and w. So here's our vector v, and here's your vector w. And it says perform the following operations, then calculate the magnitude of the resultant. So here's another vocabulary word, resultant. Okay, which means the answer or the result of the two vectors. Okay, resultant is another vocabulary. So v plus w. V is 3 and 2. Plus w, which is -5, 4. Okay, so we're going to do the x stuff added together, Now 3 minus 5, right, that's the x stuff, comma, we're going to add the y stuff together, 2 and 4, 2 plus 4. Okay, to give us the vector negative 2 comma 6. Right, 3 minus 5 is negative 2, and 2 plus 4 is 6. So then the magnitude of the resulting vector, I don't know, we'll just call it, nope, we can't call it v, we got to call it something else. Maybe we'll call it u. There we go, how about we call it u? The square root of negative 2 squared plus 6 squared. Okay, so the resultant is always a Pythagorean theorem thing. 4 plus 36. The length or the resultant of this is the square root of 40, which is a little bit bigger than 6. So let's take a moment and pause and see what that looks like if we were to graph it. So let's put these on here. V is the vector 3, 2. Okay, so vector 3, 2 goes from the origin to the coordinate 3, comma 2. So here's the vector V. And then we have the vector W, which is negative 5 and 4. So 5 left and 4 up puts us there. So here's our vector W. Okay, so then what is the result when we add these two vectors together? Well, there's a couple ways to do it. One of them is called the parallelogram method, where you basically make a parallelogram out of your vector. So we're going to take our V vector and we're going to recreate it here at the end of W. So that's 1, 2, 3, 1, 1, 2, right? So this would be the V vector again, right? The same side. Parallelogram means we have the same length and the same slope. And then here we have your W vector, right? So it makes a parallelogram. That's why they call it the parallelogram method. So the resultant is what happens when you start at the origin and you go to where these things intersect. Okay, so that is the answer of the vector V plus the vector W. Okay, so that is the resultant. So let's see if it's the same answer as what we got from our calculation. This vector is 1, 2 units to the right, and then, or left, and then 1, 2, 3, 4, 5, 6 units up. So sure enough, this resultant, which I called u a second ago, is the vector negative 2 comma 6. Okay, so we can do it geometrically, right? If we put it on a grid, that's called adding geometrically. Or we can do it algebraically, which is just adding and subtracting, right? The algebra. So there's two methods we can use to calculate the resultant of the operations of two vectors. Okay? So we can do it on a picture using the parallelogram, or we can do it as algebra, right? Algebra is usually pretty simple, pretty easy to do. So how about W minus V? W is the vector minus 5, 4, minus the V vector of 3 and 2. So once again, we do x to x. So minus 5 minus 3. And we do y to y, 4 minus 2. Okay, which looks like we're going to get the vector minus 8 comma positive 2. Okay, so this is going to be the result of our vector when we subtract them, v or w minus v. So then what is the magnitude of this vector? I don't want to call it anything. So the magnitude is once again with the Pythagorean theorem. So that's negative 8 squared plus 2 squared. I guess we don't need parentheses for a positive, which is positive 64 plus 4, which is the square root of 68, which is, again, a little bit more than 8 if you're going to decimalize it. So let's see what that would look like if we were to do that on our grid over here. Okay, so what does a subtraction of vectors look like geometrically? So to do w minus v, we're going to first plot our w vector, which is minus 5, comma 4. Okay, so let's put this on here, 5 left and 4 up. Here is your w vector. Okay, now minus v, so v was a vector 3, comma 2, which is 3 right and 2 up. So this is positive v. So what about negative v? Well, the negative v is where you make everything in your vector negative. So negative 3, negative 2. In other words, the exact same length in the exact opposite direction. So this is negative v. Okay, so we're not adding them, we're going to add its negative. So the w vector plus the negative v vector. Okay, so once again we're going to do, well, let's do another way. No, let's do the parallelogram method. So parallelogram, we're going to make our parallelogram, right? It's going to have the same length over here. And then there's your w, and then our other one is our v, right? Same one over there. And then the resultant vector goes from your origin to where they intersect. Okay, so that's the answer, right? That's the resultant. The result of these two vectors is that purple thing, which is 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2. There we go, 8, negative 8, and 2. Okay, so if you're doing this on a grid, be very careful when you are plotting your coordinates, right? And be very, very astute when you do that. And that's exactly what we got as our answer, negative 8 and 2. So now we have a little something special, 2 v's. Okay, so we have 2 times the vector v, which was once again 3, comma 2. And then we're going to minus w, which was negative 5 and 4. Okay, so this is a scalar multiplication. We're going to multiply. It's the same thing really as parentheses, just distributing. So this vector is twice as long as the v vector. So in other words, 6, comma 4 is double the v vector minus negative 5 and 4. Okay, so let's do this one. We have 6 minus negative 5, which is the same thing as a plus. So 6 plus 5 is 11. And then we have 4 minus 4. 4 minus 4 is 0. So our resultant vector is the vector 11, comma 0, which the magnitude of is pretty easy to calculate in this case, because 11 squared plus 0 squared, well, that's just the square root of 121, which is back to 11. Okay, so 121 is a perfect thing, so we can do that one. So what would this look like if we were to graph it? So 2v minus w. So let's do 2v. So 1v was 3, comma 2, right? So that is 1v. And then if we do another v from there, we go 3 more right and 2 more up. So this is the vector 2v, right? Twice as long as the original v vector, but continuing in the same direction. So there's our 2v. Now remember, it's minus w. So w was minus 5, 4. So minus w is going to be positive 5 and negative 4. So this is what the negative w vector would look like in component form, the opposites, so positive 5 and negative 4. So we're going to use something called the tip-to-tail method. In other words, where 2v stops, this is where we're going to start drawing w. So imagine this is your origin for w. We're going to go 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4 down. So this is our vector minus w, right? This is the negative of w. And if you can see this, right, now we're going to make a triangle. So if we're using the tip-to-tail method, we get a triangle for our answer rather than a parallelogram. And this is, in fact, the vector that goes directly along the x-axis and ends there at 11, comma 0. Okay, so this is the 2v minus w vector, which ends at 11, 0. Okay, and then our last thing is something called a unit vector. Okay, similar to a unit circle, a unit vector is a vector with length 1. So let's find the unit vector for v, for vector v. Now there's 2 steps. Number 1, we have to find the magnitude. Okay, finding the magnitude of the vector is first. And then the second thing, magnitude of v. And then the second thing is we're going to divide the components of v, of our vector, by your magnitude. Okay, so we're going to take the v vector, find its magnitude, and then we're going to divide the x and the y parts by that magnitude. Okay, so let me show you what we're trying to do. 3, 2. Okay, so here was v, 1, 2, 3, 1, 2. All right, so here's v. Now imagine a circle with length of 1, right, a unit circle that goes around here. So the unit vector is going to be this vector in the same direction, right, but only having 1 unit. This is going to be the unit vector for v, in the same direction as your original vector v, but only 1 unit long. Okay, so let's do that by first finding the magnitude of v. The magnitude of v is 3 squared plus 2 squared, which is 9 plus 4. 9 plus 4 is the square root of 13. And then it says what we want to do is divide v. So we have the vector v, 3, 2, and we're going to divide that. In other words, multiply by 1 over root 13. Okay, so dividing is the same thing as multiplying. So we're going to distribute this into both of our terms, just like we would do if it were a point or some parentheses. So the unit vector is going to end up being 3 over root 13, comma 2 over root 13. So if we were going to use the Pythagorean theorem to find that thing's length, we would come out and figure out that it's going to be 1. So that is if you want to leave it regular. Some of your teachers might want you to rationalize it, which would end up being 3 root 13 over 13, comma 2 root 13 over 13. So if your teacher wants you to rationalize and not leave radicals in the denominator, then this would be your final answer. Okay, me personally, I am okay with you leaving your answer with radicals in the bottom. That's okay for me. But you need to do what your teacher wants you to do. Okay, so there's some basics, some intro to vectors. They have a magnitude, which we always find by using the Pythagorean theorem, and they have a direction. Okay, hopefully this helps, and we'll see you on the next video.